Hello, Lafayette third graders. This is Mrs. Zablotny, your IB coordinator, and we're going to be talking about forces today. Well, what is a force? Is it just something we hear about in Star Wars, or is it something else? Well, let's get started and find out. So, forces are pushes or pulls that can cause objects to move, stop moving, change speed, change shape, or change direction. Forces between objects can cause a change in motion. An applied force is the force with which an object has been pushed or pulled, and we're going to look at applied forces more in a little bit. So one kind of force is called a contact force. A contact force has to touch an object to be able to affect it. One kind of contact force is friction. Friction is a force that slows down an object when it rubs against something. So if you rub your hands together, you can feel the friction between them. It gets really hot. Friction slows things down when two objects rub together. So if you look in the picture, there's a pushing force pushing the box, but the friction is pushing against it, and that slows the box down and makes it move more slowly. Air resistance is another kind of force, of contact force. Air resistance is a force that slows things down that are moving through the air. It's a type of friction that's sometimes called drag. So if you have a parachute, for example, that's in the air resistance is pushing up against the parachute and it's slowing it down as it's falling to earth. A third kind of contact force is water resistance. Water resistance is a force that slows things down that are moving through the water, and you can really feel the water resistance when you're swimming in a pool. Another kind of force is called a non-contact force. Non-contact forces act on objects from a distance without touching them. Gravity is the first kind of non-contact force. Gravity is a force of attraction that pulls between two objects. So in this picture, there is gravity between the floor. Gravity is acting between the floor and the bouncing ball. Static electricity is another kind of non-contact force. Static electricity is a force that attracts objects that have electrical charges on them. It's a pulling force. Now you get static electricity when you rub a balloon on your head, and you can see that the girl has rubbed balloons and the static electricity is now pulling the balloon to her head. A magnetic force is a third kind of force. A magnetic force is a push or a pull exerted by a magnet. And if you've ever played with magnets before or worked with them, you know that metal objects do not have to be touching a magnet for the magnet to pull it toward them or attract them. Let's take a closer look at forces and how they act. So, forces can change the shape of an object. Forces can make things change shape. Some objects stretch and bend when a force is applied. For example, with this bow and arrow, pulling on the bowstring applies a force, and pulling on the string changes the shape of the bow. Forces can also change the direction of objects. As the ball strikes the ground pushes against it. The force of this push causes the ball to change direction and bounce up again. The force exerted by the ground causes the ball to move in a new direction. Forces can also change the speed of an object. Forces can make things speed up or slow down. If something is not moving, a force can make it move. When the foot kicks the ball, it applies a force. The force of the kick makes the ball go from standing still to moving away. Some forces act over a distance. Some forces can act on objects without touching them. Remember, that's called a non-contact force. The force of gravity pulls the pear down toward the ground. The ground does not need to be touching the pear to apply the force. Let's take a look at how some forces act. So we're going to look at a website now where we can experiment with force. Force is measured in newtons, not fig newtons. These are special newtons that have to do with force. It's a unit of measure like inches or yards. We're going to put an applied force on the box that's on the skateboard. The mass of the box is 50 kilograms. We're going to see what happens to the speed of the box as we apply different units of force. So first, we're going to move the amount of force to the first bar and apply 107 newtons. We see that the speed goes up to the second long line. Okay, now let's reset it. Still got 50 kilogram box. Let's increase the speed. Let's increase the force to 300 newtons. Okay, this time the speed went almost up to the second long line. So when we increase the force, we increase the speed. All right, let's see what happens when we apply a force of 500 newtons. We've got our mass, we've got our speed. Let's see what happens. 500 newtons. Wow. This time when we increased the force to 500 newtons, it went all the way up to almost the fourth long line. So we can see that as we increase the force, we also increase the speed. Let's reset it. And let's put something heavier. Let's put a refrigerator. The mass of the refrigerator is 200 kilograms. I wonder how that is going to affect the speed when we apply a force of 100 newtons. Okay, look at that. We've increased the mass of our object, so when we applied the force of 100 newtons, it went much faster than, much slower than when we just had the 50 kilogram box. Remember, then it went up, the speed went up to the first long line, or the second long line. All right, let's restart it. Let's put the refrigerator back. Let's increase the speed, the force, to 300 newtons. Okay, increasing the force increased the speed, but not as much as when the mass was smaller, not as much as when there were only 50 kilograms. Okay, are you ready to increase the force to 500 newtons? Do you think it's going to increase the speed? Let's see. 500 newtons. Okay, it did increase the speed, but again, oh no, you know what? I forgot to put the refrigerator on. Let's stop it again and reset it. Put the refrigerator on. Mass, speed. All right, 500 newtons, let's go. Oh my goodness. Look how much more slowly it went at 500 newtons than when there was a lower mass of 50 kilograms for the box. Okay, now what happens, let's reset it. What happens when we apply a force in the different direction? Is the box, if I apply a force to the left, is the box still going to move to the right? Let's see. Let me get our mass. Let me get our speed. So, oh, I did it wrong. Too many things to think about. I'm going to do it. This time I'm going to move it 100 newtons to the left. Okay, so this time we applied a force in the different direction, so the object is moving in a different direction. Let's reset it. Let's apply 300 newtons of force in the opposite direction. The speed increased, but the direction is different. All right, let's do one more. I'm going to do 500 newtons to the left. And this time the speed increased, and again, it's moving to the left. So the direction of the force determines the direction of the motion of the object. There are a lot of fun ways to experiment with force and motion. Why don't you try out some at home? Thanks for listening.